Hi guys, welcome to my channel. Today let's solve today's daily question and let's deep dive into the description. Today's description is fairly simple that we are given nums consisting of n positive integers. We'll compute a sum of all non-empty contiguous subarrays of the array and creating a new array of n into n by n into n plus 1 by 2 numbers. We'll return sum of numbers from left index to right index given that indexes are that are provided to us are one index. So one index indices are nothing but one. Will start from one, but in our CPP, we'll use zero-based indexing where indices start from zero. So let me just take this example: 1, 2, 3, 4. In this, the total number of subarrays that would be possible would be one, along with 1, 2, 1, 2, 3, 1, 2, 3, 4, followed by 2, 2, 3, 2, 3, 4, followed by 3, 4. Or I also need to add 3, followed by 3, 4, followed by 4. So let me check how many have we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So with the first element, I'll get 4 subarrays. With the second, I'll get 3. With the third, I'll get 2. With the fourth, I'll get 1. So it's the opposite way. If I have n elements, then for the first element, for the first number, I'll get n subarrays. Second, I'll get n minus 1, followed by n minus 2. And then for the last element, I'll end up with 1 subarray. So the total number of subarrays here would be n into n plus 1 upon 2. And let me check the constraints of n that's provided over here. N is 1000, so I guess we could follow the brute force approach here as well. So let me do that brute force approach. Uh, I'll just take an vector and v. I'll call it a v. Now let me start proceeding. How we put this earlier, and I'll take a pointer to check the current sign. Okay, we'll start from I till n. So my current sum would be nums of j added. So you got this point. So first at the initial stage, my I would be at 0 and j will be ranging from 0 to 3. In the other side, first 1 will be considered, next 1, 2 will be considered, next 1, 2, 3, and next 1, 2, 3, 4. Similarly, 5 is 1, then starting 2 will be considered, followed by 2, 3, and followed by 2, 3. So I have this, then I'll just push back my current sum into B. And having said that, I'll just need to sort it out now. Sort v dot begin, v dot end. I'll keep a track of two variables. One is for mod to find a modulo number. 1 in 9 plus 7. Why 1 in 9 plus 7 is this is a nearest prime number that's lesser than 32-bit integer. And why we'll use a prime number is because there won't be any other multiple. So mod will be 0 only in either of the two cases, that if number is 0 itself or if our number is 10 power 9 plus 7. In between there won't be any other factors for it. So we'll consider using 1 in 9 plus 7 and it's a nearest 32-bit. So let me just start from left minus 1 because we need to subtract 1 because we were given 1 based index, and to make it a 0 based index I need to reduce minus 1 of it. I'll just call other sum variable to be initialized with 0, and now my sum would be incremented by v of I, and sum should be percent equals to mod. I'll simply return the sum. Let me check this out if this is working fine or not. So this is working great. I'll just add these pointers over here specifying that I do not need any standard input or output libraries to be loaded from C while compilation time. So my complexity would be fairly decreased, not complexity, but time would be fairly decreased. So it's working fine. So we get 73% people and it's fine. I also feel that if we initialize this array with zeros, then that would be great. So I'll just int total LE. I'll call it total LE, and out of it I'll do n into n plus 1 and followed by divided by 2 to get the total elements of it. So this would be total elements and this would be 0, and int idx currently would be equal to 0. So I'll just call v of idx to be cursor, and v of idx should be incremented after it. So this is the same. First v of index should be will be stored with the current sum followed by idx plus plus, because this is a post increment. Post increment in the sense increment it after performing a function. So now let me submit this out. I guess it should. No, it's working fine. So let me submit this out. Feel free to add anything in the comment section if you found anything is unclear. Thank you.